Hi guys, welcome to another LeetCode Daily challenge. Today is 18th of July, and the question for today looks like is number of good leaf nodes pairs. Okay, so we're given a root of a binary tree and an integer distance. Pair of two different leaf nodes of a binary tree are said to be good if the length of the shortest part between them is less or equal to distance. Okay, return the number of good leaves. Leaf pairs, number of pairs we have to return. Okay, first question: are these nodes unique? Node values unique, number of pairs in the range. Cool. And then this. Mm, yes, that is my primary concern. Are these nodes unique? Root of a binary tree, just a normal binary tree. Number of good leaf node pairs. Okay. Mm, okay. Okay. So this. I can think of something. So let's say we eventually I have all the leaf nodes in some store for me. Okay, now I need to find the distance between every pair. So I can put two for loops, and I can find who is the lowest, like lowest common parent of both of these. So for 4 and 5, lowest is 2. What is the distance between them? The path is 2, so 1 and 2. Now next is, let's say, 4 and 6. What is the distance between them? Lowest common is parent is 1. Distance is 1, 2, 3, 4. 4 is not less than 3, so we ignore that. So 4, 5, and 6, 7 are the only answer. Correct. Here distance is 3, output is 1. So this is a leaf node. Leaf node 3, 3 and 4. So there is 3. Okay. Yeah, so lowest common parent of these two is 1. This distance is 2. This distance is 1. Sum is 3 equal to this. So that is fine. Okay. So it looks like for every pair of leaf nodes, let's say 5 and 6, we find the common parent, lowest common parent, so which is 1. How do we get the distance? So let's say we have this level. Okay, this is 1 level, this is 2 level, this is 3 level. So the difference of level. So 1 minus, sorry, 3 minus 1 is 2. So this side is 2. Again, 3 minus 1 is 2. So 2 plus 2, 4 would be the path length. Correct. Now the concern is, how do we find this common parent? Maybe we can, while traversing down, store the path to each leaf node, and then later on we can see what is the common point between these two paths. The common point would be the parent, and let's say we have the length, sorry, what is this, height of the parent stored somewhere. uh, yeah, let's do that. And I think I have one concern, that one here is, okay, so what if we get a uh, oh, how do we? So when I have a common parent, I need the level of that parent. Correct. Now level I can store in a map. Map would come from value, and now values are common. Then that will be a problem. Node val distance is 10. The number of nodes in the tree is. Let's do one thing, and let me modify something here. 4 3. I'll make this 4 4. Is that possible? Why is this answer getting ruined? Oh, for because I've returned one. That is fine. So this one is still returning. So I don't think there is any criteria as such for the values. Yeah, the values can be anything. Now that is the problem. How am I going to store the parents? Mm, I need to find the common parents. Yeah. Okay, I think I can have something else. So one, two, three, four, 5, 6, 7. So what I'm thinking of now is, let's say somehow for every node, let's say 2, I get 2 arrays. One is a set of left children, one is set of right children. Sorry, set of right leaf nodes and left leaf nodes. So for two, I'll get two arrays. Let's say this one will have four, this one will have five only because there is nothing else. Four and five, nothing will happen. Okay. Now we do a cross, cross checking. hmm So these are all the nodes whose lowest common parent is two. Correct. Now, so parent is fine. Now these nodes they should come with their level. So the level difference we can check with the parent. Okay, that is one thing. Now next thing is lowest common variant is there. What is level difference? So five and this level would be one. Level would be one. One plus one, two. Okay, and then both of these together, I would put in a new what do you call list, four five, and I'll return four five together from here. So one would get four five from here, six seven from here. Now you do a cross checking. So four, four six, four seven, five six, five seven, six seven is already somehow processed. Okay. Now the concern is returning them. Correct. How are they getting returned? So at three, let's say this one comes from left, this one comes from right. Both of them need to be put in the same array and returned as once right. Okay. Passing the root for now. Mm, okay, let's do one thing. I can't pass the same array till the bottom because then it will be a call by reference and then there will be a lot of mix match. Let's not do that. So level is zero. At least we can do that. Um, let's just start doing something. We can figure something out. Shouldn't be this, but okay. Let's see. And call this level. So mm, so now this is a leaf node, correct? Okay. Uh huh. So I need to do two things. I need to put its value somewhere. Okay, let's do one thing. Let's make a map. Lev, I'll call this. Then when it is not this level dot put the root comma level. Okay, so the level is stored now. Now I need to return this in an array list, correct? Or array which whatever is fine. But I'll just return from here. Problem is, yeah, I think I got it. So if both are null, right, meaning this is a leaf node, new return new array list. Uh, how do I just put something in this? Again, I forgot. Ah, this is of tree node. Let me pass in the tree node only. Tree node temp to new array list. Then it is temp dot add the root, and then return temp. Yep, and then this will be the return type of this method. Okay. Otherwise, right? Otherwise, what is going to happen is parent level we have. Now we'll have two array lists. One would be left, one would be right. Let's say we are talking about two here. Okay, this two. For 4 and 5, this code would be sufficient. For 2 now, I'll make two calls. Good good pairs, right? What is it? Root dot left level plus 1, and same for the right one. Good pairs, right level plus 1. Okay. So now I have the left this thing and the right this thing. Correct. Correct. Now for tree node A belongs to left, and for tree node B belongs to right. So we are doing a left right good pair checking. Okay, now this and this. What is the distance going to be? Correct. So one is A's distance from the parent. So map is what lev. So it will be lev. Okay, it is okay. Lev dot get A minus level plus lev dot get B minus level. Correct. So force distance from the parent, 5 distance from the parent, sum it, you get the total distance. Now, if this is less than equals to capital D, I'll initialize this answer plus plus. Correct. Int D. Here D equals to distance. Control Z, Shift Tab. Okay. Capital D is initialized. Now if the distance is in control, okay. Now what we do is left dot add all, right, correct, and I'll return left. So all of these together haven't returned, only leaf nodes are there. Correct. Let's say I'm here, I have all these here. In left only everything gets added, left gets returned, but as a right, now at one, again I have the same thing and this should be fine. Let's give it a try. Okay, return. Um, this is fine. So we'll need this. This case should not happen. This is like just a safety check. Okay, perfect. So this is 1244. Yeah, my confusion is if I make 1244. This is fine. What if I make this one also 4? I'm just concerned about duplicate node values, which is working fine here. That's good. Perfect. Okay, so let's go about the approach once again. I'm not able to take this picture that side. Let me try to explain it here. Okay. So first of all, we need. So question is distance between levels. What is the distance between levels? Distance is going to be whatever their lowest common parent is. A left's distance from that plus right distance from that. Correct. The 4 5's common parent is 2. Left distance is 1. Right distance is 1. Correct. So this is 2 total distance. Now when I say left distance, what is left distance exactly? Left distance means how far they are from each other. Now I introduce the concept of levels. So this is level 1, this is level 2, this is level 3. It's the height from the root or whatever. Now you see the difference here is 1. What is force distance from 1? 2, which is 3 minus 1. Correct. So that is why we have this map of levels. We're storing levels. We increment the level every time. We make a recursive call. Whenever we reach a new node, we save its level. Correct. So this is my first step. Why am I saving the entire root and not just the value? Because I am not sure if the root values are unique. That's why I'm storing the entire root, because that is going to be unique. So I have stored the entire this thing root. Now we know how I'm going to calculate the distance. Correct. Now this distance has to be calculated amongst, like, one in a pair. One guy should be from the left subtree, one guy should be from the right subtree. If that is the case, that would mean that both of their common lowest common parent is my current node. Correct. Now let's imagine things for two. Okay, let's say I somehow got 4 from one side and 5 from another side. One thing I'm going to be perfectly sure about is their common parent is 2 only, no one else, because this is the point where they are both merging. Correct. So 2 is the common parent. So we have solved our first problem, which is finding the common parent. So 2 is the first parent. Now second problem is the distance. Now, since we are at 2, we know two's level, which is 2. Now, 4's level is saved somewhere. Five's level is saved somewhere. What is it? His level is 1, his level is 1, two's level, his level is 3, his level is 3, two's level is 2. Now we find the total distance. So 3 minus 1 plus 3 minus, 3 minus 2 plus 3 minus 2, which is 1 plus 1, 2. So 2 is the total distance. Now I have the maximum allowed distance stored somewhere. I compare and then I increment the answer. Now I want to return from 2, correct? I want to go up. How am I going to do? I am going to add all the leaf nodes together. So I'm going to remove this, and 4 and 5 are together now. Now both of these will get returned upside. At 1, what is going to happen is 4, 5 is from this side and 6, 7 is from this side, correct? So this means that the common parent for like 5 and 6 is 1. Common parent for 4 and 6 is 1. Like one guy from this side and one guy from this side, the common parent is going to be 1, because this is the point they're merging together, correct? And then we repeat the same process. We keep doing this. Got it? Yeah, that's all. Uh, yeah, that's all for today. Please let me know if you have any feedback regarding my solution, my question, the way I explain things. But otherwise, I'll see you guys in the next one. Thank you.